Now we're going to do is we're going to build a special point VOP to sort of rein in the velocity over the course of the life of these particles. Because we're going to use the velocity vector to drive the orientation of the particle. As if, it's flying up from somewhere and then moving in a direction, we often use velocity to be able to orient something so it follows whatever path it's going in. Let me turn on the velocity vectors here. Go to Visualizers, V. Actually, let me roll this back and play it. You can see we've got our velocity vectors. And the thing that I'm mainly concerned about is this. Let me scroll in and show you what's going on. When our particles hit these little nooks and crannies in our geometry, you can see how the velocity vectors just kind of are shaking around, right? Because they're kind of colliding around and they're just jittering in these little tiny areas. And what that's going to affect, if we do this sort of orientation by velocity, it means that when our objects kind of land in these nooks and crannies, that vector is going to affect them and they're just kind of shake around and rotate around. And we want them at the end of their life, once they've hit these little places, just to be calm and languid and not be jittering around. That would look wrong. But we like what's going on up here because we can see that we have these nice vectors curving over as the particles move up to down. That's good. But when we get down here in these nooks and crannies, that is something that is just going to look ugly. So what we're going to do is we're going to control that vector over time. And I'm going to show you how to do that. I'm going to make a point VOP. And I'm going to call this process V. And I'm going to make that green. Okay. Now, this is the idea of what we're trying to do, is that obviously we've got our velocity vectors as we see them, which is good in the beginning, but by the end of the particle's lifespan, those vectors are no good anymore. And we can control things over time because we've baked in that color value from 0 to 1 over the life of the particle. So basically what we're going to do is we're going to build sort of a custom system to be able to fade from this incoming velocity state to a fixed velocity state at the end. All right, so let's do this. So first off, I'm going to do a normalize to normalize our incoming velocity. And then next up, what I'm going to do is I'm going to make a constant. Make this a vector with a value of 0, -1, 0. Okay, and then what we're going to do is I'm going to do a mix. And it's going to be at 0, our fixed vector, and at 1, that mix will be the normalized incoming vector. So the mix is basically a crossfader, right? We're going to use this to crossfade between the actual incoming velocity and this fixed velocity that we're setting. And then I'm going to have that blend go into V. And you can see already that changes because the mix by default is set to a bias of 0.5 to blend in between them. But we want to set that via a ramp. So we're going to do our vector to float, to break out of CD just one of the color channels, and we're going to use that to drive a ramp. Ramp parameter, hit the P key, and this is going to be called V blend. And it's going to be a spline. Okay, and now I'm going to wire the red incoming color into that, and then we're going to have this ramp drive the bias of this mix. So we can control over the life of the particle what the blend between the incoming and then this fixed velocity value are. So now let's go look at this ramp, right? So what we want to do is we want to say at 0, at the beginning, we want this to be 1. We want to use the incoming velocity value. So right now, since this ramp is just, 1 across the board, nothing's different. We still get this weird jitteriness at the end. What we're going to do now is take this second point, I'm going to change its position to 0.25 and make its value 0. And now I'm going to take this first point and change the interpolation to Catmull-Rom to make that smooth. So now what happens is a quarter of the way into the life of the particle, it blends to our fixed vector from the incoming vector. So you can see at the beginning, yay, everything's great, everything's following the way it wants. But then once it hits that point, it fades that vector into our constant, and we're not going to get these things jittering around. So we get this really nice motion out of the volcano and then more of a fixed motion as these things fall. So this is just a great way to show how we can take these vectors that have been created for us that are great and then sort of rein them in to control the kinds of things that we want to control. So a great mix of sort of automatically generated stuff and then manually controlling, tweaking that.